Sorry, folks. I forgot to start streaming. Oh, I can't stream because I don't. Let's see. Let's see if the wireless was down earlier. At least I'm recording now, so I can upload this later.
It's fine, so I don't recommend it.
Thank you. We'll record and then I'll upload. So not too many people watch it as a live stream anyway. They just watch it later. So we are recording now, and so those who have just joined us online, welcome. Word of the day is on the screen right now. It's Equinox. We're going to talk about the program Atom Quad. You will have to show up sometime to pick up Atom Quad because I don't know how to send it, unless there's a way you can download it yourself. But you'll see I've got some cables here that will connect from my calculator to yours, and I'll be able to actually just give it to you. So that's what we're going to work with. I'll see if I can get my computer-based program to work. If not, we'll have to go to the screen a little bit. We'll just do what we need to do. Okay, so far we've looked at functions, right? This is kind of the first test. And when we did lessons 3 and 4, does anyone remember the kind of function we were working with? Linear. So we looked at functions that were something like y equals mx plus b. And those are linear. And oftentimes they would graph as, they would always graph as a straight line. Okay, and when we looked at it, x was the input, right? Y was the output. And then there's these numbers, these letters, B and M, and they told us something about the function, right? What did B tell us about the function? What did we call M, the number in front of the number in front of the x? It was a slope, so it got us the steepness, whether it was going up, whether it was going down. So this was our slope. And then what did the B tell us? The vertical intercept, the Y-intercept, the starting value, all of those things. So I'll just put start because that's the shortest word I put right. So it's where we started. It's where it crossed the Y-axis. Okay, good. What were the type of functions that we just worked with on this last test? That was exponentials, and what did they look like? Y equals A times B, and the exponent, the input was up here in the exponent, right? Okay, and does anyone have a way of describing what did the graph of that look like? Wasn't straight. It was, yeah, it's easier to just kind of draw it in the air. It's kind of that J-shaped thing. It just kind of went like that, went up somehow. Or it came down. There was various, but it basically had this sort of shape, this swoosh, or whatever you want to describe it. And so what we do in math is as we examine types of functions, we actually look at the graph. The graph will determine sort of the family of functions. So all exponentials had a graph that looks in this sort of way, either increasing or it could have been decreasing. But what makes all that happen was that the input is up here in the exponent, and that's the variable that would change. A and B are not variables. They were fixed numbers. Once they were there, they were there. And then Y is the output. Okay. What was the function of the A letter here? What did A tell us about the graph? That was our starting value, right? You plug in 0 for x. B became, this whole thing becomes 1, you multiply, so that's your starting value. Okay, and some of you on the test, you did very well on this, you went through. If you had some errors, that's basically all you had to do is the number in front becomes the vertical intercept, which is simply 0, A in this case, right? That's what that gives us, the vertical intercept. What did B give us? the rate of change in terms of a percent. And so, and we always remember whatever it was, we'd have to take B and we'd have to subtract 100% or 1, whichever we did, and then we'd get the rate. And it'd be increasing if B was bigger than 1, because that would be positive. If B was smaller than 1, this number ends up being negative, so that's a decrease. Okay, so that was really the two things we tested you mostly on, was can you find the vertical intercept, which was just the number front, and then can you find the rate by taking the base, subtracting 1. Or the way I preferred is as I take the base, turn it to a percentage, and then subtract 100. It's the same thing, but it gives you your rate as a percent right away. Okay, so that was sort of the other half of the test. That was the big deal. And then there was a few solve the problems by finding intersections, and then there was a regression, and that was it. So there was really only 4 topics on that last test. So take a look. If you did well, great. If not, we can go through review. And again, there's always the option just to do test corrections, get half the points back, or to retake the test at a later time, and we'll get you full points. Okay, so, and you know, I'm kind of, it's more dependent upon you being ready than upon me being ready. Well, a little bit of both, but I've got extra exams, but it's mostly when you're ready, let's do it. And if it's later in the semester, that's fine too. Okay, so we have 3 more types of functions we're going to deal with, only 3 more. The last 2 we sort of take together because the technology is about the same for solving them. But the next one, it will take over two chapters, and we'll take it individually. And this third one that we're going to discuss, number 3, oops. Number 3 is something called a quadratic. What does quadratic mean? Well, you look at the word quad, and what do you think? Think of 4. But I don't think 4 has anything to do with it. I don't really know where the word quadratic comes from. I guess I should look it up sometime. But what a quadratic is a function of the form y equals a times x squared plus b times x plus some number c. Okay, so we now get a more complicated equation. And just here, A, B, and C are going to be fixed numbers. Once we have them, they'll be fixed for a particular equation. But we use it as sort of as a general form. So this is called our standard form of the equation. We'll talk about that in the book. But the key part is there's 2 x's in here. One's an x squared and one's an x. So there's 2 places for input. So we'll highlight those or underline those in red. So the input goes both here and here. Now we talked a little bit about what exponents do. Which of these 2 terms, the x squared or the x, do you think is going to be more important for the behavior of the function? The x squared, because when you square x, it's going to get bigger, right? For the most part, as x gets bigger, x squared will be bigger than x itself. And what you see here is a quadratic kind of has this back part. What kind of a function does that look like? It looks exactly like a linear. In fact, it is. It's sort of the linear part of a function. So if we just had this part, we'd have a straight line. But when we add on this x squared, different things happen. I won't call them weird, but stuff happens. Okay. So let's see what happens to this kind of graph. So part of it, I'm just going to give you an overview. We're going to say this does happen, and then I'll give you the tools to work with. and we'll actually explore them happening. So when we add this x squared, well, let's think what happens when we square a number. If I take -5 and I square it, what kind of number do I get? Positive or negative 25? 25 is correct. Well, if the negative's inside, this is -5 times -5. That's going to be a positive 25. Now, if I didn't have those parentheses, you were right. That would be a negative 25. So that's an issue that we have to deal with. Or actually, I got to stop using that. I had a conference over spring break, and my mentor was telling me, I use that word to me. He says, people use issue as if it were a problem. But he says, you know, it's not. Issue is an issue. Problem is a problem. So this is a problem, not an issue. Okay. What if I take +5 and I square it? I get positive 25. So what we're going to see, and what I'm doing is I'm sort of putting in x values on either side, and if I put in -5, I get, say it's over here, I get a positive 25. If I put in +5, I get a positive 25. Let's just jump down. What if I put in 3? What's -3 squared? Three times 3 is 9, so negative times negative, so it's going to be +9. I'll just put a dot about there. What if I take +3 and I square it? It's going to be 9, so if this was 3, then can you see that what we end up getting, I guess I should switch to red color. I'll do orange. What I end up getting with a quadratic function is something that basically has a U shape to it. And what makes that happen is the squaring process. If I've got a negative number and I square it, it becomes positive. If I have a positive number, I square it, it's positive. So we get this U shape. It's symmetric too. We get this symmetry. So this is what a quadratic equation is going to look like, the graph. It's going to be a sort of standard U shape. What we're going to do is as we explore, we see the value of A. If A were negative, it would take these positive values and make them negative. So the two kinds of quadratics we get is we get quadratics that open upward and quadratics that open downward. But they all have a U shape. Okay, either a U up or a U down. That's the basics. And so as we go to examine this, just like when we were dealing with linear functions, we spent a lot of time on figuring out how to find out slope, right? The number in front of the x. We also spent time on figuring out how to find the y-intercept, the vertical intercept, or the b value. When we were dealing with exponentials, we spoke quite a bit about the value of a, or once we were given a, what that was, or if we were given the starting value, how to come up with the function. And then we worked with how to find this rate, so these important parts. Sort of similar with the quadratic, it's a little more complicated, but what we've got to be able to figure out is the components that make each quadratic, each U shape, a little different. Either a wider U or a narrower U or moving the U around. It all comes from these letters A, B, and C. Okay, so we're going to look at a few examples. How do we figure out what A, B, and C is? Some of it's really straightforward. Some of it's you've got to do a little bit of work to figure that part out. And then I'm going to give you the Atom Quad program. We'll pull it up and we'll see that once we know A, B, and C, we just pass that off to Atom Quad, and Atom Quad does all the dirty work for us and gives us our answers. Okay. So I'm going to take a picture of this screen. And let's call this call that. Okay. And then we'll ask for a new clean page. And let's do this. Let's just go ahead and work off script. Okay, so we'll come up with a function here. So, what's the value of A? Good. What's the value of B? And what's the value of C? -5. Good. Perfect. You're like 25% there. Okay. Any questions on that? Okay. Good. I'll give you two hard ones in the same question. What's the value of A? Good. It's got that invisible 1 in front, right? So we want to think this really as, oops, -1. Yeah, make that a little cleaner. So think of that as -1x squared. Good. So A is -1. What about B? Next number is 7. Why would it be 0? You don't see an x. Good. It's what made it. There's really, if you want to think of it, there's this plus 0x in here. We don't write it because it's invisible. It's 0. But in this case, when you don't see an x, that means that the b is 0. And you're going to see when we get to atom quad, we have to put these in. And the mistake I'll see students make, they'll put the -1 in for A, but they'll put the 17 in for B because it's the second number. But that's not right. B is 0, and then the 17 is what? Is the C. Okay? Good. So as we identify these, y equals x squared plus x. So now let's talk about A, B, and C. A is 1, okay, so the invisible 1 again. How about B? It's also got the invisible 1. When there's a number there, it's usually easier to see. How about C? That's the 0. Okay, you could think of it as a +0 if you wanted to, but you're going to have to enter all of these three. And I'll show you how this connects to formulas that have been developed over hundreds of years that also do all of this. It's just that having the technology to carry out the calculations makes things go a lot smoother. Okay, let's do one more. Let's see. So let's talk about A, B, and C. A. Well, this is one, it's not quadratic because A would be 0, right? And if A is 0, we don't have a quadratic, so we're throwing it away. That's a linear. So this was a tricky one, or I wonder. Yeah, there is no x squared, so this is not quadratic. It doesn't belong in this chapter. Okay, so I don't think they'll throw many at you like that, but when you see the program I give you, if you try to put in 0 for A, it will tell you that's not a quadratic. Go get another program. I don't do those. I only do quadratics. Well, it doesn't quite say that, but it gives you an error message. Okay, so we don't have to worry about it if there is no x squared. Okay, but you're right. We could put 0 for A, B would be 2, C would be -5. But again, this method, what we're going to be learning about quadratics only applies when we have an x squared. If we've got an x cubed, that's not. We're going to do something different because again, what you're finding is that the power on the x, the exponent on the x squared, x cubed, x to the 4th. The higher the power, that's what controls what the graphs will look like. And again, you'll go through this in 150, and you'll spend probably a couple weeks exploring the differences of different polynomials, different powers. But this class, we just get you started. We're only going to look at x squareds. And so I'm able to give you a program that does only x squareds. Okay. next thing we need to be able to do before we go too much further, let's take a picture of this. Sometimes they don't give it to us in standard form. So they might give it to us sky blue. They might give it to us like this. Yes, we have to deal with these. What's the A, B, and C? We have to do some work first, right? Okay, and I saw the hand signals for FOIL, right? So we have to distribute everything. I call it double distribution because you just distribute everything, however you want to refer to it. So yes, we take the first term times the first term. The first term times these are outer terms. So if you're following FOIL, there's the first, the outer, and then we do the inner and the last. So the first term, x times x, gives us x squared, x times x. And then we take x times positive 2. Would you agree that that's plus 2x? Negative 4 times x, negative 4x. And then negative 4 times positive 2, negative 8. We can combine the two like terms in the middle. So we end up with x squared, positive and negative, so we subtract 4 minus 2, that's 2x. Since the 4 is bigger than 2 and 4 is negative, it's a negative. And then negative 8. Now can we answer the question of what is A, B, and C? Yes. So now that we've got it in standard form, what is A? B is very good. C is okay. So there's that issue. One more issue. When we're finding A, B, and C, we have to have it so that the Y is by itself. And actually what we're going to find out pretty soon is that the form that we really use is that ax squared plus bx plus c equals 0. So we want 0 on one side. And this is a specific place. When y is 0, where are we on the graph? When y is 0, we don't go up or down. We're on the x-axis. Okay, so to even start thinking of the x-axis as the equation y equals 0. Okay, so we're going to use that concept quite a bit. We'll see how that all works. But let's just do one more. It's a little tedious, and then we'll get really jumping in and doing. We'll be finding the four, as I say, the 4 important points, and we'll actually be doing 2 chapters of work in probably like 15 minutes because you'll have so much power with this program. It does everything, but it will allow you to see the graph and then also see the results. So that's kind of how we're going to jump, and we're going to be able to do everything. And then probably, let's see, what's Monday, on Wednesday, we'll come back and pick up the pieces, and we'll see how everyone else starts with the formulas. We're going to start with the technology that gives us the answers, and then we can go back and use the formulas, and they'll make a lot more sense that way, and we'll have a lot more success. So what was I going to do? Oh, I was going to show you one more. So let's say we had, let's make one really nasty one. Before I go too far, well, let me finish this train of thought. Plus 8 equals 16. Okay. So notice there's no y in here, but we're going to be able to analyze these kind now. I could find the solution here. I could graph both sides and find where those intersect, just like we were kind of doing before. We'll do some of that, but I'm going to show you how if I get it into the standard form of a quadratic, I can figure out what A, B, and C is, and then I can use atom quad to figure everything out for me. But let me back up a little bit. This first one, this x minus 4 times x plus 2, when I first wrote that down, did you see that as a quadratic initially? No, you didn't see an x squared, did you? But we figured out when we take x times x, we get an x squared. So it was sort of an x squared in disguise. Had its big nose and mustache on or something. This one, does this look like an x, like a quadratic? Not so much because the x doesn't have a squared on it, but we see the square up here, and so maybe this is a little bit more that, well, maybe eventually it'll be an x squared. Okay, so how do we get this into standard form? Can we distribute this 3? First the parentheses. I'm glad you, hold me back. We got to take care of the exponents. Parentheses and exponents got to be done first before we can start doing with that 3. So what we're going to do is, what does this square mean? X squared, or this thing squared. Well, what does 3 squared mean? Doesn't it mean 3 times 3 and then becomes 9? So couldn't we just say that this is this 3 on the outside, this is x minus 3 times x minus 3. That's what it means. Okay, so it's a way of not having to deal with it directly. Okay, so that's all we changed, is we wrote it out here. And then now what do we need to do? Distribute. Okay. So we're going to take that 3 and distribute it. Do we distribute this 3 to both of these parentheses things? Not sure. Yes. Maybe no. No. Good. So if we took 3 numbers, 2 times 3 times 4, do we take 2 times 3 and 2 times 4? Or do we do 2 times 3 is 6, 6 times 4 is 24. That's how we, when it's just all multiplication, that's how we do it. So that's what this is it's 3 times this times this. So what might be easier to do is just distribute the 3 to this first term, and that gives us 3x minus 9. And then now we do the FOIL on these two, okay? But you'd have to be careful. If you distribute the 3 to the second one, you've actually multiplied by 3 times 3. You've gone overboard. Okay, so that's, and again, all we're trying to do is get this in the form so we can figure out what the A, B, and C are, and then the real heavy lifting is going to be done by atom quad. Switch back over to blue. Okay, so then we take 3x times x, right? 3x squared, 3x times negative 3, negative 9x. Then we take our negative 9 times x, another negative 9x, and then we take the negative 9 times negative 3. Negative times a negative gives us a positive. 9 times 3 gives us 27. We still have the plus 8, and we still have the 16 over here. Okay. We can combine these like terms, 9x and 9x. Be careful, I was subbing for a class this morning, and it was a similar type issue, and someone looked at this and said that was 0 because they cancel. And I used to do that a lot too. I usually can catch myself. They're both negative, so they don't cancel, right? They become more negative. They're the same sign, so we add them. 9 plus 9 is 18. This actually becomes negative 18x in the middle. Okay. The 3x squared stays up front, so we'll do that. This is a 27 plus an 8, so I could do that, 35. So that's a plus 35 equals 16. Now can I just say what A and B and C are? What you're going to see with Adam quad, I have to get one side equal to 0. So I have to get all the numbers to the other side. So how could I get that 16?
Divided by all the 16.
Close? Subtract 16. If I divided by 16, what would be left would be a 1. So this is in algebra, remember, we're always making either 1s or 0s, and we can get them confused. It's easy to confuse them. This time we want to make a 0 on one side, so we subtract. Divide when we need to make 1s. So both are great techniques. So we're going to subtract 16. I'm going to do this sort of at the level up here. Subtract 16 here. Subtract 16. So I can write my final answer over here. So I'm going to get, what, 3x squared minus 18x. And I'm going to take 35 minus 16. And that's going to give me 17? Or is it 18?
19.
19? 19, yeah. If it was 15, it would give me 20, then take one more away. Good. That's a better way to think. I don't know what I was thinking. Yeah, I do know what I was thinking. I was thinking of 30 instead of 35, so it's 19. Negative or positive?
Positive.
Positive. Positive 19, and then it's equal to 0. Now we can say what A, B, and C are. This is how Adam quad's. The nice thing is Adam quad's going to give you this reminder when you see the program, because at the top, the first thing it does is it says 0 equals ax squared plus bx plus c. So there will be that reminder there. And again, we just want to come down here and say, well, a equals 3, b equals negative 18, and we'll just squeeze it in here, c equals 19. This will get posted in the notes section. Okay, so how do we use all this? Well, that's what we need to do to look for, let's see, the 4 important points. This thing will draw a quadratic for me. Draws ellipses and circles and stuff, so I'm just going to have to oops. How can I get rid of that? I don't really need that one. Okay. So now a quadratic might look something like this. A little bit, mine's a little bit wimpy, but we'll see. What if I told you there are 4 important points on this quadratic that we want to find, and a lot of times one of those points is part of our answer. Where are the points that you think we might be interested in? Four points. Good, okay, and that gives us 2 of the 4. We're interested, where does it cross the horizontal axis? That's going to be called an X-intercept.
Y-intercept.
And the Y-intercept is the other one, so we've got 3 of them. Intercepts. So the Y one's down here. So Oftentimes there's two. We're going to see sometimes there's actually no X-intercepts because you see if this U was pushed up, it would never cross. So that's a possibility. There's also a possibility of only having one if it sort of just kisses the graph. We'll take a look at some of those. It'll always have a Y-intercept. And we're going to see that's actually one of the things we'll be able to spot right in the equation itself as well. You're going to see actually it's just the value of C. It's that number by itself is always the Y-intercept. And there's one more point. It's not quite as clear here, but what does this, when I've got a U, what do I have with a U? On the what? On the curve, the point of the curve. So yeah, the lowest point. They call that a vertex, okay? We call it the point or whatever. Yeah, so this might be, so it's, I don't, that wasn't well drawn, but it's not as clear. There's a vertex. Okay, so that's a fourth important point. There's a mathematical way to find each of these. Again, the Y-intercept's the easiest one. You just look at the equation and you figure out what C is, and there you got your Y-intercept. So the Y-intercept I'm going to go ahead and put down here. It's going to be the point when X is 0, Y is going to be the C. Okay, so you'll see that. That's pretty easy to spot. Atom quad will give you that one as well. The X-intercepts are a little bit harder because what you're doing is you're solving the equation. What is the characteristic that every X-intercept has? What is the value that every X-intercept has? What is the same for every X-intercept? Y is 0. Good. So the X-intercepts will have a 0 for the Y, but then you've got to figure out what these are. And again, that's mathematically fairly complicated. It did take people, some smart people, hundreds of years to figure out a formula. They finally figured it out, and we've now burdened generations of people with the quadratic formula. And fortunately, you will get it, but you will also have atom quad, which will do it for you. So that's, atom quad does the horrendous calculation. Sometimes it's not so bad, but sometimes it's just real tedious. When I was teaching in Kazakhstan, that students could do it in their heads because they practice so much. But again, I thought they mathematically they were very sharp at doing formulas, but then I'd ask them, well, what does that mean? I don't know. It's just the number. It's the formula. They could do formulas, they could do answers, but then if you ask them what does it mean, they didn't spend much time on that. We are going to spend more time on what does it mean, and we're going to let the machines give us the answer. So we got like our assistants here, focusing on what it means, and then we'll go back. We'll also learn those formulas for times we might need. But these are the four, I call them important points that we're going to need. Atom quad will give them all to us. Another thing you might notice, again, that my drawing's not all that great, but the vertex also forms a sort of a symmetry. Let's go ahead and go with red. So if I come through here, sort of, if I go right through the vertex, I get sort of this line of symmetry. Symmetry have two M's? Doesn't look quite right, but we'll look it up later. It's in the book, I'm sure. Symmetry. So if you cuts it in half, it's the same on the left as it is on the right. So there's that line of symmetry. What do you notice? Let me draw this a little bit better. I'll just make my vertex point a little bit bigger. What do you notice about the line of symmetry and the vertex, the relationship between the vertex and the line of symmetry? Well, they intersect. Yeah, the line of symmetry goes through the vertex. That's what I was trying to get at. Yeah, you got it. It goes, so whatever the vertex is, it's going to have an x coordinate and a y coordinate. The x part of it also is going to be our line of symmetry. Okay, so we're going to see that. Atom quad gives us the vertex. It will also give us the line of symmetry, but you're going to see how those two are connected. So once we get the vertex point itself, we also have the equation of the axis of symmetry. Okay, so that's another thing that'll be on the test. You'll be looking for axis of symmetry. As soon as you get the vertex, it's just x equals the x coordinate. Okay. What else do you notice about a quadratic? Is it always increasing, or is it always decreasing? Or is it constant? Or is there another option?
When you said the vertex was the lowest point, that also means it's the highest point. Right?
It could, yes. If it's the other way around, it could be the highest point. Exactly. So it's, I always think it's either the bottom of the valley or it's the top of the mountain. Exactly. And so if we've got valleys and mountains, what happens on one side of a mountain? Anyone ever go up a mountain? One side it drops down, the other side you got to go up. So when you go up a mountain and then you come down the other side, you're never always going up or always going down. You're going up and then down, or down and then up, depending upon where you're at. The valley, the same thing. You come down one side, then you go up the other side, or vice versa. So with every quadratic, there's a part that is decreasing, and the other part that is increasing. And you notice if it was a mountain, if it was an upside down one, it would have increased first and then decreased. Valleys always decrease and then increase, going left to right. Again, as far as when does it decrease and when does it increase, what's sort of the key point?
It'll be that our horizontal line when
Here?
it goes down into the decreasing. We'll see if it goes up.
Okay, right, good. The vertex itself, or that line of symmetry, those both are the sort of the places where it changes. So again, that's why that vertex is so important. We go from decreasing to increasing, or vice versa. Okay.
So our vortex would be our point that we're going to take it from if we were
Yes.
going to go up or if we were going to take it down.
Yes. The vertex is always the point, either the lowest point or the highest point. But it's a very important point because on one side it decreases, the other side it increases. It's also the place of symmetry. So it's like, yeah, it's this point we're trying to get to. If you're a bird, it's the point you want to get to fly to, right? All birds always go for the highest point. At least the ones I know of. It seems like they always go for the top. And then also we've got these intercepts. And where all this comes from is if we were to flip this around, so I'll just do a little side view here. If I were to have one that went like this type of quadratic actually is a way of modeling or describing the path of a projectile. So if I throw a ball, in fact, I'll show you. They won't see this on the live stream, but watch this, you can see this. So I'm going to throw this, the effect of gravity. Watch how this falls across the room. See that? It kind of went up and down. It actually formed a perfect quadratic graph. It always happens. Now when you throw a baseball hard and it goes straight, that's different. But if you lob it, you always see that sort of up and down. But you see a quadratic formula in the air. The same things happen with missiles. In fact, one of my professor I admired the most at Portland State University, who taught me math after I had not done so well the previous semester, so I was taking a math class a second time. He's dyslexic, but he also served in the Korean War, and his job was he sat in a tent and did math calculations because they didn't have computers back in those days, or maybe they did, but in the 50s, and he was calculating how do we aim the guns if we want to hit here. And he would do the quadratic formula. So the things you're doing, they didn't even have these things. They had to do all of this by hand, sitting in a tent, a little mathematician, Okay, 45 degrees. No, 47.5 degrees because we want to hit this target. So he used all of these things. That's basically one of the main uses for quadratics is projectiles. Okay, it can also be used. These upside down ones get used in business plans, like, you know, the more you buy, a lot of times they give you a greater discount to a certain level. So there's kind of it's an optimal place where, you know, you buy in bulk, but after you buy too much bulk, then you've got to store it, so it becomes more expensive. So they use this also in different business models. And a lot of times what you're looking for is that vertex gives you the place where that's the optimum, and afterwards it's going down, or one way or the other. So you're trying to maximize your profit. You want to be at that vertex. Because on the other side of the vertex, costs are going up or something. You're not getting as much profit. So that's the other application. But a lot of our applications we'll look at, it's anything that operates under gravity. There's certain factors, and what goes up comes down, and it comes down in a nice little quadratic arc. Okay, you could actually take a picture of it, you'd see it, and you can overlay it, and then you could use your regression abilities and come up with the actual formula and then reproduce it. Kind of cool. Okay. Does that sound? And that's basically everything you need to know. So you ready for the test? Not quite, but you guys actually are more than you know. You're almost. You just need to practice now. Okay. So what I'm going to do is so we save that. We'll go there. How about, is there anyone who would like to learn how to transfer a program to a calculator? You would? Okay, because then I'll teach you, and then you'll do it to everyone else while I try to get mine set up. So we got these two antennae that come off. So let me show you. So this one needs this kind of a plug. So then either one of these will work. Okay, so what you want to do, anyone who wants to learn, come on over. Let's see if I remember the link key. So link is yellow, so we go second link. And you're going to receive. So when the receiving one receives, this one is going to go second link, and this one's going to send, and what it's going to send is a program. And I'm going to send you Adam Cloud. So first I'm going to get you ready to receive. Now you're waiting for me. I'm going to mark Adam Cloud, and then I'm going to transmit it. Goes like that. Adam Cloud done. Now you have Adam Cloud.
Oh, so that's what, when I bought the computer, they gave me this little, okay, that's what it's for. I thought it was to charge it.
Now let's see. Oh, let's see if you can do a second one. Or someone want to take over and do the second one? And then I'll let you do everyone else's too.
Do you need to copy this?
Actually, no. Yeah. That'll, yeah. You want to receive, enter, and then turn mine into the second. There you go. And go down to programs and hit yeah, the first one. Actually hit it one more time. That's already selected. And then just go over to transmit. And it's in there to there.
So
Just like that, it's done.
it's gonna stay in there.
Yeah,
Oh,
forever.
is that- oh, okay.
And I'll let you guys, yeah.
Let me see what type you have. Oh, you have both.
Yeah, you can use either one. While you guys are doing that, I'm going to see if I can get mine to.
Basically, second link. Okay, good. Receive, enter, and second link program. And the first one's already selected. And then disconnect.
That's it.
It says still receiving. It's okay?
Just hit enter because it does say done
Oh, yeah.
or clear, and you'll get back. You'll be okay. Yeah. Sometimes it freezes and. Yeah.
Second link.
Let's see, where is it? Okay, now it's coming. So
Something's not right because for some weird reason it's not transferring the atom to this chapter.
okay, that happens sometimes with these newer ones. So let's try.
Second mode.
Is anyone else? Let's do this. Anyone else has this particular? Let's try getting these, and then maybe sometimes it works if I give it to you. Yours might do better. So yeah, it's newer software, but it still works on it. My emulator over here isn't. Sure.
In this exercise, I didn't get to copy everything, but I will check later on.
Mm-hmm.
I was trying to do this. If I just do this directly instead of doing this, would I get the same result or not?
If you did it right, you would. Yes, you could, because it'd be x squared. Then it's minus 9x.
It would be positive 9.
Oh, actually 6x. Sorry, yes. So you get x minus 3. If you squared, you get x squared.
And then
You get plus 9 here, but you do get a middle term of negative 3x and negative 3x, so you'll get negative 6x. So some people follow a formula for doing this because it is.
I didn't.
Yeah, it's x minus 3, x minus 3. Some people, what they'll do is they'll put x squared minus 9.
How do you get a 6?
The way you get the 6, you get x times negative 3 and negative 3.
I was trying to do just like this
Oh,
with the
yeah.
opening.
No, that doesn't work because it's 2 of these. So you still
Really?
have to.
Yeah, because I was trying to do that in my head when you were doing the
Yeah.
other thing, and then I was like, it doesn't sound like I will get the same
Yeah.
result.
There is a formula. People can't do it, but you have to remember there is going to be a middle term. It's 2 of these. So 2 times 3 is 6.
So nice.
Yeah. Okay. We all done? Okay. So I'm gonna. Let's see how this works. Try to give the people on the live stream as close to the real life experience as possible. Oh. Let's see. It's probably going to be upside down for them, though. We'll see. Okay. There we go. Sorry, those who are watching when you watch this video, you might want to look away while I do this, or otherwise you might get kind of motion sickness. Okay. I think that'll. Well, yeah, but I'm watching it here. It's kind of like an earthquake's going on. So I've got to zoom in on this a little bit. Let's see. Let me go here. turn on a lamp. A little bit better. Not much. Okay. So what I'm going to show you, piece of paper now. Got to go from high tech to low tech, but okay. So now I'm going to show you how to use Atom Quad to get the 4 important points of any quadratic. Okay. In fact, actually, we should probably pull up the ones we already did, but we might do that. Okay, so let's somebody give me a quadratic equation. I've been making them up all day and I'm getting tired, so.
1.
Okay. Plus or minus 6? Plus or minus? Minus. And then one number on the end? 2. Plus or minus? Plus. Okay. So we're going to be able to graph this. Now you could use your graphing calculator, just plug it into the y equals and get a graph. But the cool part about Atom Quad is if when we put in just the values of A, B, and C, it will also produce the graph, and it fits the window to usually a pretty good size. Sometimes it's not perfect, but see. The second thing it'll do is I'll show you. We come back to a step, and it will give us the X-Intercepts. It will give us the Y-Intercept. It will give us the Vertex. It will give us the line of symmetry, and a bunch of other stuff that we don't need, but it gives it all to us. Okay, so the way you go about using Atom Quad is you go to Programs, because it's been downloaded to you, and you should. Did it work on? Okay. It was the secondary one that worked. Sometimes, for some reason, mine's a little bit of antisocial and didn't want to talk. Yeah, okay. So you go here, you see Atom Quad. Okay, what you do is you just, as long as it's the one that's highlighted, if it's not, arrow down till it's highlighted, hit Enter. That's going to execute it. Sort of. It brings up a line to execute it, and then you just hit Enter. Okay, and so you should see this. And the first line should say if ax squared plus bx plus c equals 0, ... Okay, so that's the key part is we have to basically have the numbers all on one side. You can have y equals or you could have 0. Okay, but if you have equations where there's a number on the left side, you have to get all the numbers over to the quadratic side. Does that kind of make sense? It'll make more sense when we actually do problems, but and then it's going to ask for you what is a, and then what. So what is a?
1.
So we put in 1. It's not 1x squared. It's just the 1. It just wants the coefficients in front. The programs have the x squared built into it. So we just put 1 and then we hit Enter, and then it asks us for b. What is b? -6. And now this is a key part. So if you do it wrong, if you use this negative here, that's not a negative, that's a subtraction, you'll get an error. Because it's going, what you talking about? What you talking about, Willis? Anyone know that show? Different Strokes? I know, I was a kid too, so yeah. What you talking about, Willis? Okay, so we put the -6. And it's okay. Otherwise, it would have given me an error message, and then I'd have to go back and enter it.
On this program, anytime you mess up, it won't let you continue. It tells you what's wrong.
Usually, yeah. But there's a case, like if I mix up, I put the C in for B, it doesn't know that, so it'll go ahead and let me do that. But yeah, syntax error, like putting in the wrong negative, that one it usually picks up on. And then for the last, for C, what do we put in? C's just 2, so nothing special, just put the 2. Now watch what happens. I'll hit Enter, and I get a new menu. Okay. And in this new menu, I'm going to walk you through a few things it does. And again, I've been using this for more years than I can remember, at least 5, maybe 10. I remember I didn't find it till I got here, but I used to teach at Oregon State for 6 years, and I didn't have it there. So one of the things that it'll do, you'll find out if the first thing you do is go to number 5, which is options. I'm just going to push the number 5 key. And the two options is it can give you answers in fractions or decimals. Which would you prefer? Thank you, me too. So I switch it to decimals at the beginning because the default is fractions. So it'll give you the answers, but a lot of times it's kind of in funky fractions, I call them, and it just doesn't make any sense. But if it gives me in decimals, then it's all good. So that's one of the first things. Just remember to turn it into decimal mode. Usually the other thing I'd like to do is I like to take a look at the graph to see what it looks like. So I'll do number 3, which is graph. Notice 4 will graph, but it graphs and exits the program, which we're not ready to do yet. We'll use that option later. So it resizes the window, and it gives me that kind of a look. And so when I'm working on something, I can kind of do a rough sketch of the graph. Now mine's a very rough sketch. It wasn't as accurate. I don't know how much it zoomed out or anything, and if it's too fast, what could I do? I can say show it again. So I just hit the number 3 because it's going to draw it, and then it will come back to the Atom Quad program. So yeah, maybe it looks like it's going through 0, 0, but we'll find out. Okay, so far. And so as you work through these, one of the ways you might want to just do a quick sketch of what you saw in the graph, and then you can label points, and maybe I might need to adjust mine a little bit. Okay, so I've seen the graph, I've put it in. Where do you think I go next? View results. View formula. I'll show you what's view formula. It's just not too big of a deal, but these are things that are going to be in the book. This is a quadratic formula. That's the funky formula it uses. It's going to do all the calculations. You'll see that in the book. It also has this thing called a discriminant. We don't even use that. It used to get used, but it'll give you the results, but we don't worry about it. This is an important part because it does allow you to verify what you put in. Because oftentimes I'll find students, when they do a problem, they'll get it wrong because they thought they entered in -6, but if they come here, they might see, oh, I actually put in positives. I forgot the negative or something. So this is a way, maybe on a test, you want to double check to make sure you actually put in what you thought you put in. I'm usually the one that needs to check that because I'll think I put something in and I end up putting in the wrong thing. But this is a way we could check to make sure we got the right stuff. But other than that, it's really not all that useful. Where the real use is coming to view the results. This is where it's going to give us all our answers. Okay, and that's why I've got this little graph drawn, is because now I can, as it gives me the answers, I can label them. So I'm going to show you how to do that. So view results. The first thing it gives me is my X-intercepts. And notice it's X, 0, and here's the 2 values. So yeah, I've got mine maybe not drawn so well. Let me fix mine a little bit. Like that. So one of the X-intercepts is here at 0.354, 0. So that's one X-intercept. And the other one's over here at 5.646, 0. Okay. So it's kind of a way that you can visually, sketch the graph, and then you start labeling them. So as they ask for answers, when they ask for X-intercepts, you're, okay, there they are. So far, so good?
What did you press to get that?
Just enter.
Enter.
I went to number 2, which is view results. You got it now? Yeah, so you got to be in the program.
Yeah.
Good, okay, so you get that. What else do you want to know about this quadratic? How about the Y-intercept? Hit enter. It gives you the Y-intercept. So then again on your graph, you could actually label it. It's the 0.02. And do you see why it might be the 2? We put this 2. When you put in 0 for x, right, this becomes 0, this becomes 0. All that's left is 2, the value of c. So here it is, 0, 2. This is sort of just my scratch work that I put down. And I'll tell you what, when I write whatever question they're asking, your answer probably comes from one of these numbers that we're coming up with. Okay. What else did we? So we've got 3 of our important 4 points. What's the last one? Vertex. We hit enter, and what does it give us? A vertex, exactly what we wanted. But it's even nicer. Not only does it tell us it's a vertex, it tells us that that vertex is a minimum. So it helps. It kind of helps out. And then the vertex is sort of the lowest point. It's this point here. So I could label that as the point x is 3, y is -7. And notice how it puts those decimals on it. I don't really need the .00s afterwards, but so it's given us our vertex. It's not as clear to see on the, let's see if I can make the, yeah, we'll live with it. So maybe that's a little bit better. Okay, what else do you want to know? What else have we talked about with a quadratic? The what? Line of symmetry. We hit enter, and what do we get? We get a line of symmetry. Now notice the way it does is it's x equals 3, but notice that 3 coincides with the x-coordinate of the vertex. So that's what I want you to do, is I want you to let the atom quad get the answers for you so that you can focus on understanding what those answers mean, where they're coming from. And then we'll talk about the formulas of how we could calculate these. And they're not that bad. It's just once you start calculating, you focus on calculations and you forget about what you're trying to do. This one, you've got the help, so you can really focus on what you're doing. And what's that line of symmetry? You could draw it on your sketch here. It's the line that cuts the thing in half. And it goes through, it's x equals 3. It's the vertical line, x equals 3. And I think that's about the end of what atom quad actually gives us. It gives us, it tells us the domain is all real x's. So in Math AES, they do ask this. I just push it off because it's not really an important question at this stage. But in math, they're always asking, what's the domain? And when they ask for the domain, what else do they ask for? Range. So they give us the domain, and you'll see with all quadratics, it's all real x values. And then it will give us the range. It's saying it's all y values greater than or equal to -7. So notice from here, -7 was the y value of the vertex. Every y value is bigger than that because it opens upwards. So this atom quad will help you with those questions about range that Math AES will ask you. Again, I don't worry so much about them as a concept because you will deal a lot with domain and range in Math 150. We do get to talk a little bit more about domain in the next sections because there's an issue with domain. But when there are no problem with domains, this time we have no problems with any x values. We're very inclusive. And then I think it gives us something else. It gives us the discriminant. And I'll just tell you, in the old days before we had graphing calculators, they would use the discriminant to figure out how many X-intercepts there were. If you have a positive discriminant, you get 2 X-intercepts. If you get a discriminant that equals 0, you get 1 X-intercept. And if you get a negative discriminant, you get no X-intercepts. What I like to do is just look at the graph and see how you could visually see it, so we don't really need to use the discriminant anymore. But it's the way they used to do it when I was a kid, 20 years old. We didn't have all these calculator stuff to help us to graph. But now that we've got the graphs, my preferred way would be just to look at the graph and see if it crosses the x-axis or not. Okay, but the discriminant can do that. And then when we hit enter, we're back to the menu. Okay. So at this time, you can do one of two things. If you have a new problem, if this gave you all the answers you needed for the problem you're working on, you could go to number 6, which will restart. It will ask you for some new values for A, B, and C, and you could do just the next problem. The nice thing about doing that is it will remember your options, so it will keep you in decimal mode. The other thing you could do is you could do 7, which will actually exit atom quad, and then it resets itself, and so if you go back in later, you then have to reset your options. And there's a 4th way to exit, and that's with graph and exit. The nice thing about graph and exit, that's what I'm going to ask you to do now, is it draws the graph, it it leaves all the information that it's gained for you. And what this has kind of scared me the first time I saw this, so that's why I want to, I don't want you to do this in your bedroom while you're alone and it might be dark, and this was kind of scary. If you go to y equals, look what's there. Now this 17.5, I put that in earlier for something, I don't know. But did I put that in? No, and did you put yours? No. Adam Quad put it in for us. But that's what scared, I didn't know calculators could do that, so I thought, oh man, this is like a ghost has taken over my calculator. Literally, it did scare me. And I go, oh, it must be in the, and then I got looking the lines of code and what this Adam Miller guy, and you'll see if actually when you exit, it does say Adam Miller, and I think it's 1999. So 20 years ago, he put all this together, and it's a pretty advanced code. There's a few things, if I could do the programming, I would change, but I don't know enough to mess with it. I've tried it a little bit, but I only made it worse, so I'll just leave it with it. But he's got it in here. So later on, when we need to do things like maybe we want to resize the shape of the graph, we could do that. We could also go to the table.
Excuse me, how do we go back to the menu? I got stuck in restart. I put 6, restart, and now I'm there.
You got this is like Willy Wonka and the Chocolate Factory. The only way to get out is to go forward. So you have to put a new, So once you've restarted, you have to put the values back in and sort of restart, yes. Let's see, table set. Oh, it's on auto? No, it should be on auto. Maybe dependent should also be on auto. Maybe that's it. I'll just make that 0. I want to go to the table. There it is. So for these x values, it's giving me some y values. Okay. When we get to the test, I'm going to remind you about this because this is a feature you're going to be able to use. I'm going to give you a quadratic, and I'm going to ask you to fill in a table of values. You could use Adam Quad, graph and exit, and you'll get your values right from here. But you have to sort of learn how to play with the table a little bit, and you can scroll around in it, all these kind of things. But we'll get to use the table. So Adam Quad's great, but there's sometimes we need extra values, and we'll do that. In fact, actually Wednesday I have an activity I used back in the day when I was at Oregon State. We let's see, who were the two? There was two big heavy hitting baseball players that were having like this home run, and this was back in like the 2000s or something. McGuire, anyone? McGuire, I can't remember his first name. And there's any baseball fans? Okay, then I'll stop here because I'm not that great. I mean, I played baseball, but yeah, McGuire, and there's Sammy Sosa, and Mark McGuire. There we go. Anyway, we got a problem that was sort of based on their home run hitting, and we'll actually take you through where we take a formula and we answer some questions, but we'll use Adam Quad, which I didn't have back in that day, and you'll see it'll make getting those answers a lot easier. The other thing it allows us to do is on a graph is we can actually trace, and so we can move along. So notice it's giving me, for these x values, there's those y values. And you can even enter something in, like if I enter in 4, x equals 4, hit enter, it says that when x is 4, y is -6, and it jumps and it goes right on the graph. If I say x is 5, hit enter, x is 5, y is -3, and I see it right here. So this is, it's a very powerful tool. And that's what I like. Adam Quad will sort of do all the assistance and give us some answers. We could manually find these X-intercepts just by graphing and doing it, but what this does is it allows you to start working with the homework quicker and not have to worry about all the details. By the time we're done, we'll come back and we'll look at how to do this manually. Again, the reason you'll need that is for your next Math 150 class, because you'll be doing these same types of things with other type of equations, not just quadratics. But quadratics give us this time where we can sort of have some training wheels on and learn to ride the bike first, and then once we get good at it, you can keep this as long as you want, but you're going to have to take the training wheels off and because you're going to be doing with x cubes, x to the fourth, and the same things will apply, but then you'll have to do it manually. Okay, or write a program that will handle those. I haven't seen one. There might be one out there. If you go to ticalc.org, I'll write that down. I think it's ticalc.org. That's where I got this program. And it's a place where people upload programs that they write to the TI calculator. So if you have a chemistry class, there's chemistry apps in there that have like the periodic table and stuff. That's why sometimes they don't let you take these calculators into certain tests, because they can do a lot. Okay, so you might find some things for other classes as well. You might find some, and what I'll do is I'll download them to my computer, upload them to here, give them a try. But there's some calculus stuff in there, and a lot of them, they give you these visuals so they help you understand the concepts. It's not just about getting the answers, but getting the answers in a way that help you understand what you're doing. Okay, and again, so everything we'll do from here, I'm going to give you some formulas. The formulas, what they're going to do is they're going to help us find one of these 4 points, or maybe 2 of them. So we'll look at the formula way to do it, but we already have a way to get there, right? We have this sort of automated atom quad way. We'll also be able to do it manually with the calculator, and then we'll also be able to do it with algebraic formulas. We'll see how they all connect together, and we'll figure out which one feels best for us, and we'll be fine. But the more interaction you get with all of them, I think it'll help. And you'll see as you study, you have to take however many more math classes, a lot of times that happens. They come up with a formula, and then you just have to know how to use it. Statistics is one that's that way. Kind of goes through with the formula. But basically, you've got, in using atom quad, everything that you're going to need for this section. You'll be able to do both 6 and 7 with this. We're going to come back and look at a few things, because some of them they'll ask you with the formulas and such. We'll show you the same thing. But how was that? Want to try another example, or feel comfortable? What do you think is going to be the hardest part of this whole thing? Finding A, B, and C, right? This is because you have to have A, B, and C to use atom quad. You can't just put the full. Now, some of those formulas you could just put in the calculator, graph them, if that's easier for you. But there'll be a few of them that they give you that are, factored form and stuff. We'll also be doing some factoring, but again, I'm going to show you most of it can be handled with this. And I've even got a cheat way to, if you have a difficult time factoring, we use atom quad to get the X-intercepts. From the X-intercepts, we get the factors, and we're good to go. Okay. And that's the skill you'll need for 150, to be able to go back and forth. So, just about done anyway. Take atom quad with you, start working through the homework, and see how when they ask for an X-intercept, you know how to do it. All you got to know is what are A, B, and C. Plug them in. It'll give you all your answers. It'll give you the graphs, and try to make those connection of why certain things are the answers. Look at the formula. Spend the time doing that, and then we'll look at an example on Wednesday and keep moving forward. Whatever the syllabus says. I think we got like 2 weeks or so before the next test, so we have lots of time to work on it. But I try to give you small tests, yeah. Keep you moving forward. All right. Hope the nobody was live streaming, but hopefully this recording uploads pretty good. We'll see.